The following content is for entertainment and educational purposes only. It does not constitute means for diagnosis, healthcare advice, nor treatment. Make use of a qualified healthcare professional for such purposes.
Anova stands for analysis of variance. So it analyzes a multi-group comparison and it determines that the manipulation was effective or not. It's the ratio of the variance between subjects over the variance within subjects. The important thing to know about Anova, any Anova, is it's going to tell you whether there was a significant difference in the means of your groups, right? In the one-way Anova, it's just those 3 or more groups. All it's going to do is say there was a significant difference in there somewhere. It's not going to tell you which group it was, like which groups had the significant difference. To do that, you got to do what's called post-hoc tests, follow-up tests. And that's what determines, right? So you don't know whether A is less than B and B is equal to C. You just don't know from the F value that you get. You have to do additional tests after that. So this is what an output would look like in SPSS for an Anova. And you can see up there, it's circled what's important. I'm going to move it to the next slide where we can see kind of a zoom in of that. So this right here, and this is another, again, important thing that you guys need to know for in your paper and just for this class, how to write the results of an F test, right? So you get a table like this, right? You can see that you've got a column for sum of squares, you got a column for degrees of freedom, you got a column for your mean square, your F statistic, your significance, which is your p-value, and then your partial eta squared, which is your effect size. And the way you would write that out to write into a manuscript is italicize F, parentheses, and then you've got the degrees of freedom for your numerator, which is this one, the 2, but you do the 2, and then the 192 is the error. So you see how this says error? That's the one that's going to come second. So this is degrees of freedom error, and then it's going to equal the F value that came out of your data, just like with the t-test. And then you're going to report your p-value, which again, because it was 0, it's showing it this way to say it's smaller than this really small number. And then if it wasn't, like let's say it was 0.013, you would just write equals 0.013. Okay? But if it's because it's 0, we're showing it this way. And then you would always report your effect size as well. So we always report the effect size. And you get that from this partial eta squared when we're talking about an F test. And here you can see a line chart. Again, the dots on this represent the group means, right? So the average for everybody in the positive group is that number right there, 42, 43. And again, the error bars are going to usually be the standard error. You'll find out that when you go into Excel or SPSS, you can put error bars that are all kinds of stuff. You could do a confidence interval, and you'll see this when you're reading research as well. Some people report the error bars as just one standard deviation below the mean. Some people do it standard deviation. Some people do it as a confidence interval around the mean. You're going to report standard error on these bars. Why this is a line chart when we have categories down here? So the reason that we have this on a line chart, right, because this independent variable, right, it looks like categories. So it kind of looks like it's nominal, right, but it's not really nominal. We can think of this more like a Likert scale, which would be an interval scale, continuous, right? And 0 or neutral, which you think of as zero, right? It doesn't really mean nothing. It just means neutral, the inflection point between positives and negatives. Yes.
Questions of our, you know,
Because these are actually continuous, right? This is an interval scale because we're assuming that there's an equal space between positive and neutral, and as there is between neutral and negative. It's like you can think of it as a Likert scale, right? Where it goes like from strongly agree to strongly disagree. That's actually an interval scale. Does that answer your question?